Topic 2. Modulus inequalities. Let's first define the modulus function based on the modulus. Modulus of a number gives us the non-negative value. Like, for example, let's say if you're talking about modulus of 5, it gives you 5 only. Modulus of -5 is equal to 5. Modulus of 0 is equal to 0. So if the number is 0, obviously the modulus is going to be 0. If the number is positive, it will come out as it is. The number is negative, it comes out as positive. So basically, the modulus of a number is a non-negative value. So basically, if you consider the mod function as a kind of a machine, then if you feed value, let's say this is the modulus machine. So if you feed a number which is 0 or positive, the number will come out as it is. So it will come out the same. But if you feed a negative number, suppose -5, so this modulus machine does something inside and the number will come out as 5. So actually, if you see inside what's happening, it actually attaches a negative sign to the number to make it positive. So in other words, I can say the modulus of an unknown is the number itself. If the number is more than or equal to 0, but it'll attach a negative sign to the given number if the number itself is less than 0. So if the number is negative, it makes it negative, it acts on it, makes it negative, so the negative of negative becomes positive here. So it's been programmed to act on it. You know, if it is the number is 0 or positive, the number will come out as it is. If the number is negative, it will become negative to make it positive. So if you look at this one as negative x here, it is not actually the negative number because the number had been negative. So it touches the negative sign, so it gives you positive. So that's what the modulus function does. So if you have a modulus of some number is equal to, let's say, 10, you could say that this number is either plus 10 or minus 10 here. So if you are solving for an unknown, you know that if the modulus of x is equal to 10, then the number may be 10 or maybe it is minus 10 because the number is plus or minus 10, the modulus of x is equal to 10 then. Right. Going in for the modulus inequalities. Suppose we say modulus of x is less than 5. Modulus x is less than 5. What are the values where absolute value of x, sometimes modulus is also known as absolute value. So 0, this is 5, this is minus 5. You know that modulus of x is equal to 5 gives you x equal plus or minus 5. But if the modulus of x is less than 5, then surely the number must have been less than 5. Yeah. But how far can you go? You can go here, but you couldn't really cross this one. You couldn't cross the minus 5 here. No, you have to stay to the right of minus 5 here. So this entire zone will be such that this whole zone here to here will be such that the absolute value of every such number will be less than 5. Supposing you pick a number, and this one, let's say you have x is equal to -3, maybe -3, absolute value of -3 becomes equal to 3 here. Absolute value of -4.99 becomes equal to 4.99, which is less than 5. So as long as you don't cross these 5 and -5, you'll find that absolute value is less than 5. So I can say conclusion here is x must be less than 5 and more than -5. So I can say x belongs to -5 to +5 as the open interval. Yeah. So I could also say that not the other way of representing this one is this one. So if you wanted to represent an open interval, set of all values of x which are belonging to -5 to +5, I could also, in other words, another way of representing the same thing is that, hey, modulus of x is less than 5 here. That these are two equivalent statements. Modulus of x is less than 5, absolute value of x is less than 5 is the same thing as x belonging to -5 to +5. Now coming to absolute value of x is, let's say, more than 5, for example. So this is 0, this is 5, this is -5. What are the values of x which enjoy the absolute values to be more than 5? Obviously, the number which is more than 5 will have absolute value more than 5. And also, you'll find that as you walk to the left here, let's say you locate the number -8 maybe here, you'll find that absolute value of the -8 is equal to 8 here, and then that goes to the right of 5. So absolute value of x is more than 5 indicates that either x is more than 5 for sure, or you find that x is less than -5 here. So value of x is less than 5, -5, or x is more than 5. So what we learned here is that now, if you have absolute value of x is equal to, let's say, 10, this implies that x is equal to plus or minus 10. If the absolute value of x is less than 10, for example, this implies that x is between -10, sorry, x is between -10 and +10. If you have absolute value of x is less than or equal to 10, for example, you'll find that x is between -10 and +10 here. Absolute value of x is more than 10 implies that x is more than 10, or you find that x is less than -10, or in other words, I can always say that is either x is less than -10, or we have x is more than 10. I could also write this in an interval notation like this. I can say x belongs to right from -infinity until -10, open, or is always union, or 10 to infinity. Yeah. So if you want to indicate the entire set like this, maybe the short way or another way of quickly representing this one could be just mod of x is less than 10. So the moment you say mod of x is less than 10, that means either you are on the right of 10 here, this is 0, this is 10, this is -10. Either you are to the right of 10, or you are to the left of -10, right of 10 or left of -10. If you have absolute value of x is more than or equal to 10, this implies that either x is more than or equal to 10, or we have that x is less than or equal to -10. So you can say x belongs to -infinity right up till -10 here, closed union. You have closed 10 to infinity like this. That's where the values of x are. This is the definition of our inequalities in absolute values. Let's think of some problems just to make things clearer. So let's say the question is solve. let's say absolute value of x plus 3 is less than or equal to, let's say, 15. I can say that absolute value of something is less than or equal to 15 implies that that something is a sandwich between minus 15 and plus 15. So for all values of x which are between minus 15 and plus 15, the absolute value is less than 15. Therefore, I can say x plus 3 must be less than or equal to 15 and more than or equal to negative 15 from the discussions on the linear inequalities. You would find that I can subtract 3, therefore you have x less than or equal to 15 minus 3, more than or equal to minus 15 minus 3, therefore minus 18 less than or equal to x less than or equal to 12, therefore x must be between the x must be from negative 18 to 12. So this is where x belongs. So if you choose your x to be from minus 18 to 12, so you'll find that in this zone, you will find the solutions, of course, less than or equal to. So you have all this, this is circle darkened here, circle darkened here. So you'll find that in this zone, this inequality is satisfied. So if you plug anything between minus 18 to 12, including of minus 18 and plus 12, you'll find the inequality is satisfied. Let's take another example. Let's say question number 2 is that, let's say you have mod of x plus 5 is more than 2. So you know that absolute value of something is more than 2 implies that if you have absolute value of something is more than 2, this implies that that something is either more than 2 or that something is less than minus 2 here. Therefore, you find that x plus 2 is either more than 2, or we have x plus 2 is less than minus 2 there. So x plus 5, sorry. X plus 5 here. Therefore, you find that x is more than 2 minus 5. Transposing by addition or subtraction does not disturb the inequality. Or we have x is less than minus 2 minus 5. If we have x is more than minus 3, or we have x is less than minus 7. Therefore, R is union. So either you go here, so this is 0, this is minus 3 here, this is, this is minus 7 here. So either you go to the, to find the solutions, either you go to the right of 3, more than 3, or you go to the left of minus. And these are the values, these are the zones we'll find the solutions here. Therefore, you find that x belongs to negative infinity to negative 7, always the smaller first, negative 7, or union is always R. Or you have the union of minus 3 to infinity. Here's the values you will find the solutions for the given inequality here. So let's pick up some more little challenging problems. So let's see, we have question number 3. Say 2 minus absolute value of x minus 7 is less than let's say 10. You find that, therefore, you have negative or absolute value of x minus 7 is, or let's make it 5x minus 7. It's 5x minus 7. So less than 10 minus 2, simply transposing across the inequality. Therefore, negative of absolute value of 5x minus 7 is less than 8. Hey, this is the negative sign. I don't like in front of it here. So I'll write as 5x minus 7 is more than negative 8. Basically, I'm multiplying both the sides by negative 1. So whenever you multiply by negative, the inequality will always switch around. If you look at this one here, you'll find that absolute value of a number is always more than or equal to 0. So if you're demanding that it should be more than -8, you will find that this is agreeable for any value of x here. No matter what value of x you substitute, you'll find that the absolute value, we know that absolute value of any number is always more than or equal to 0 for all values of star. Yeah. Therefore, if I'm demanding that absolute value of something is more than or equal to -8, it's readily met because it is already more than or equal to 0 here. So if you are demanding that it should be more than -8, the demand is always met. So you'll find that this is true. This is which is always true, which is true for all values of x. Therefore, you'll find that the solution set is all real numbers, or you can write this one as -infinity to positive infinity. You can plug any value. You'll find that that holds good for any value of x. No matter what is the value of x you substitute, whether you substitute x equal to 10, or substitute x equal to 0, or substitute x equal to -10, no matter what you substitute, this will be always true for all values of x here. So that's the solution set. Let's say I make a change here a little bit. Let's say the question number 4 is that you have, let's say 2 plus 3 times 5x minus 7 is... I didn't understand. 7 is, let's say, less than or equal to 10, something like this. So you find that, therefore, 3 times 5x minus 7 is less than or equal to 8. Therefore, modulus of 5x minus 7 is less than or equal to 8 by 3. Therefore, you find that 5x minus 7 is less than or equal to 8 by 3. And 8 times 3 comes to 24. Sorry about that. This is a... yeah. So it's not equal to 8 and more than or equal to -8 by 3. Therefore, you find that 5x is less than or equal to 8 by 3 plus 7 and more than or equal to -8 by 3 plus 7 here. Therefore, you find that 8 plus 21 by 3 is less than or equal to 5x is less than or equal to, I'm sorry, -8 by 3. So less than or equal to 8 plus 21 by 3. Therefore, you find that 21 minus 8 is equal to 13 by 3 is less than or equal to 5x is less than or equal to 21, 29 by 3. Therefore, x is less than or equal to 15 by dividing by 5 throughout. You get 13 by 15. 13 by 15 is less than or equal to 29 by 15 here. Therefore, x must belong to the closed interval 13 by 15, comma, or maybe 15 by, 13 by 15, comma, 29 by 15 here. So this is where you'll find your solutions. So you have 13 by 15 and 29 by 15. So this is where you will find your solutions. So let's say we have the inequality of the type, let's say, question 5 minus modulus of x plus 3 is x plus 3 is All right. So supposing you have something like this, something simple. If you have absolute value of, let's say, absolute value of x plus 3 is less than plus 10 here is less than 8 or something, you'll find that therefore absolute value of x plus 3 is less than 8 minus 10. Therefore, absolute value of x plus 3 is less than negative 2. And you know that absolute value of any number is always more than or equal to 0. Therefore, if you are asking for absolute value of something is less than negative 2, and what would that something be? There would be nothing of that kind where absolute value of something is less than negative 2. Therefore, I would say that there are no solutions because absolute value of something is more than or equal to 0 for all something. So absolute value of m is more than or equal to 0 for all values of m in real numbers. Therefore, if you're talking about absolute value of x plus 3 to be less than negative 2, the demand is never met because the absolute values of something are always more than 0. So if you're asking for something which is less than negative 2, then you're asking for trouble. You don't have anything of that kind at all. So no solutions. Let's take up some more, little more complicated expressions. Let's say you have question 4 is the absolute value of x minus 2 is more than or equal to 5. Therefore, you find that if the absolute value of m is more than or equal to 5, this implies that m is implies that either m is more than or equal to 5 or m is less than or equal to minus 5. Or in other words, clearly that either m is less than or equal to minus 5 or we have m is more than or equal to 5. Therefore, x minus 2 must be less than or equal to negative 5 or we have x minus 2 is more than or equal to 5. Therefore, we find that x is less than or equal to minus 5 plus 2. Therefore, x is less than or equal to negative 3, or we have that x is more than or equal to 7. Therefore, therefore I can say that x belongs to either negative infinity to negative 3 union of 7 to next question. Let's say you have an equation of this kind. Solve the system. Let's say solve the system of inequalities. And the system consists of, let's say, two things. Let's say absolute value of x minus 1 is less than or equal to 5, comma is as good as and. Modulus of x is more than or equal to 2. So you got to find the solutions which will satisfy the system of inequalities. You have one component of the system, you have another component system. You have to find the solutions which abide by or agree with both the components of this system. Yeah. So supposing you have here, if I go by the first one there, I'll first digest the first inequality. X minus 1 is less than or equal to 5. Obviously implies that if you have that modulus of m is less than or equal to 5, then m is a sandwich between 5 and minus 5. Therefore, x minus 1 must stay more than or equal to negative 5 and less than or equal to 5. Therefore, minus 5 plus 1 is less than or equal to x, less than or equal to 5 plus 1 here. Therefore, you find that minus 4 less than or equal to x, less than or equal to 6. Yeah. This is the first component. When you look at the first component of the system, this is how the values should be. And now you have one more component in the system. So the other component is mod of absolute value of x, and mod of x is more than or equal to. So therefore, you find that absolute value of star is, or absolute value of, let's say, x, absolute value of star is more than 2, implies that that star must be less than -2, or the star must be more than 2. So you find that this implies that either x is less than or equal to -2, or we have x is more than or equal to 2 here. Therefore, x must belong to -infinity to -2, or x must belong to 2 to infinity here, 2 to infinity. So now I go to check, I go to satisfy both the inequalities here. Both the conditions must be met. That becomes a solution where you satisfy the first one and satisfy the second one also. So what are the values which satisfy both the things? If you look at this one carefully, the real line, this is 0. Let me just put these numbers up. This is -2 here. This is +2 here. This is -4 here. And this is 6 here. So the first condition tells me that the x must stay between -4 and 6. -4 and 6. This is where I should stay. Inclusive, of course. Inclusive of -4 here and -6 here. This is where I should stay. The second one says that, I either go and find my solution here, or I go and find the solutions here. I'm sorry, I should find the solutions here. So now if you have to satisfy both the components of this system, that is, satisfy the first one and satisfy the second one, that is a common value of x that actually agreed with both the conditions. So you can see that the common region here is the one which is overlapping, the two colors overlap here. The two colors actually overlap in this zone and this zone. So it looks like that particular value of x satisfies both the inequalities there. So such a value of x, supposing you pick one fellow here, let's say you pick -3 here, you'll find that that -3 fellow will satisfy the first one, because you'll find that -3 is more than -4 and less than 6, and that -3 fellow satisfies this one also, because that -3 either belongs here, -infinity to 2, in fact it belongs to the first part here, and or in the second one, so it belongs to the first one. So you find that taking into consideration both the things here, if you have to be satisfying this one and this one, then you must pick the value which is commonly satisfied by both of them. Therefore, we'll find that x belongs to -4 to -2 is also inclusive here. It's also inclusive. So -4 to -2, or 2 to 6. So considering all the conditions, you'll find that the system would be satisfied in this -4 to -2 union of 2 to 6 here. So this is how you respect a system of inequalities actually. So if you impose, let's say, this condition, this condition, this condition, this condition, then abiding by, satisfying all the conditions, what is that value which satisfies all the conditions, that's the kind of situation actually. So that's meaning of system. So when you deal with, let's say, system of, let's say some scientific model or something, you impose this condition: pressure must be less than this, temperature must be more than this, let's say density must be less than this. So you consider all the things there and then see what that system actually what are the temperature, density, all these conditions satisfied by, that particular system actually. So it's basically, dealing with multiple conditions in a given problem in short. So this is what the system of inequalities are. So let's take up one more. Let's say you have a question. Let's say you have absolute value of 2 by x minus 4, let's say, is more than 1, where let's say x is not equal to 4. Of course, when x equal to 4, something upon 0 is not defined. Therefore, it's given that x should not be equal to 4. Good for us. So remember, absolute value of a by b is always equal to absolute value of a by absolute value of b. So some of the properties of modulus. Absolute value of a into b is also equal to absolute value of a into absolute value of b. Absolute value of a times absolute value of b. But absolute value of, sadly, absolute value of a plus b is not equal to absolute value of a plus absolute value of b. No. And absolute value of a minus b is also not equal to absolute value of a minus absolute value of b. So there are some conditions or some things where they may satisfy, but then generally only these are two things which are satisfied. So I can say here, this is the inequality that I have. I can say absolute value of 2 upon absolute value of x minus 4 is more than 1. The denominator, if you see, actually, I'm excited to transpose. That's what we always like. If you have x plus y, x by y is equal to, let's say, z, we quickly transpose. We say that x is equal to y into z. In the case of equality, it is still fine, but in the case of inequality, you resist the temptation. So you don't transpose at once. You always analyze what you're transposing. If you're sure that this quantity is having a definite sign, supposing this, now if you have x upon y is more than z here, x is more than y into z looks very good, but mostly it is wrong. Mathematically, it is wrong, because only if you find that this y is positive, then by transposing this positive, is like multiplying both sides by positive, will maintain the equality. If this y is negative, then the inequality will switch around. So if you do not know what that y is, then you don't transpose until you know what it is. Or maybe take cases where you have, oh, what if it is positive? What if it is negative? And then you transpose. Otherwise, you couldn't do that. But then now, fortunately, you'll find that x minus 4 is, I know that absolute value of x minus 4 is always more than 0, because absolute value is always more than or equal to 0, and x is not equal to 4. So confidently, this value is more than 0 here. So if I'm multiplying both the sides by absolute value of x minus 4, it's absolutely fine, because I've analyzed that this is positive. Therefore, your absolute value of 2 is more than absolute value of x minus 4 here. It's in fact multiplying by positive. If you have, let's say, x by 2 is more than y here, I can always say x is more than 2 times y. I'm not ignorant, but I know that this is 2 is positive, so I'm actually multiplying by 2, the inequality does not reverse. So it's as good as that. So I multiplied because I know that this is positive, and multiplication by positive does not change the inequality there. Therefore, we wish to always write the variable in the left. Therefore, you have x minus 4 is lesser, because this is the lesser sign, absolute value of 2. Hey, why am I writing absolute value of 2? Absolute value of 2 is actually known to be 2 here. Therefore, you find that x minus 4 is less than 2 and more than negative 2. Therefore, x is less than 2 plus 4 and more than negative 2 plus 4. Therefore, you find that x is less than 6 and more than 2 here. Therefore, you find that x belongs to open to 6, comma, beware, x is not equal to 4, because that was provided on which the whole problem was built. So x could not have been equal to 4. That's what they are saying. So if you are considering the interval 2 to 6, remember there is a 4 there coming inside that. So just say comma x equal 4. You can also say x belongs to different ways of writing it are x belongs to, you can say, negative, 2 to 4, drop the 4, and you say 4 to 6. This is also fine. Or you can say x belongs to 2 to 6 minus a singleton 4, drop the single number 4. Different ways of looking at it. Actually, if you write this one, this is 2, this is 6 here, this is open, and here is 4. So this is also kind of a hole here. So what you can do is that you can show your solutions like this. You can show your solutions between 2 to 4 and 4 to 6 here. All these are the values where you find your solutions for the inequality here. So let's take up one more. Let's say you have, let's say you have, let's say you have, let's take up a harder one. Let's say you have absolute value of x minus 1 plus absolute value of x minus 2 is more than or equal to 4. These are very tricky ones. In the following videos, I'll take some more examples of this kind. These are very, very tricky. We'll discuss about the modulus functions, and they will discuss all these things actually. But right now, remember, these are these expressions change their nature, positive and negative, depending on whether you take x more than 1 or less than 2 or more than 2, because these numbers, you first of all what you do is that you find the zeros of these equations here. So you'll find that x minus 1 is equal to 0 implies that x is equal to 1, and x is minus 2 is equal to 0 gives you x is equal to 2. So what you do is that you look at the number line here. This is 0. 0 is not even important, actually. You don't even want the 0. So I'll take the value, let's say 1 and 2 here. So basically, there is a change, or there are things happening in the 3 zones, 1 to 2 and 2 to 2 onwards here. So you find that if your x is between, if your x belongs to negative infinity to 1 here, negative infinity to 1, you will find that x minus 1 is modulus x minus 1. If you take a value in this zone, let's say on the first zone here, if you take a value, let's say minus 10 or something, so absolute value of minus 10 minus 1, that's a negative number. So the expression will be negative of x minus 1, because we said that absolute value of m is equal to, we said that's equal to m itself if m is more than or equal to 0, and minus m if m had been less than 0. So when you plug a value less than 1, you will find that the number which is less than 1, when you plug that number less than 1 here, you'll find that less than 1, let's say minus 5, minus 1 is minus 6 here, for example. Minus 6 is negative, so in order to become positive, it has to be attached to, or attached with a negative sign. So in other words, modulus of m is equal to negative of m if m is less than 0. So you'll find that that becomes equal to 1 minus x here, and x minus 2 would become equal to, if you choose a value which is less than 1, let's say minus 10 again, minus 10 minus 2 is negative, so it becomes equal to negative of x minus 2. That becomes equal to, you find that is 2 minus x. Therefore, therefore, you find that therefore the absolute value of in this zone here, the absolute value of x minus 1 plus absolute value of x minus 2 is more than or equal to 4, implies that 1 minus x plus 2 minus x is more than or equal to 4. Therefore, we find that 3 minus 2x is more than or equal to 4. Therefore, minus 2x is more than or equal to 4 minus 3. Minus 2x is less than or equal to 1. Therefore, x is more than or equal to negative 1 upon 2. Mm, 1 minute. I'm sorry. 2 minus x. I'm sorry, I made a mistake there. This is it's not this. So you have minus 2x is more than or equal to 1. Therefore, x is less than or equal to negative half. Yeah. Therefore, the solution is x belongs to negative infinity to negative half here. So this is the solution that we found out when x is less than 1. Yeah. So now if x is between, if x is more than or equal to 1 and less than 2 here, you'll find that absolute value of x minus 1 becomes equal to, if you choose a value, let's say 1.5 minus 1 is positive, so it comes to be x minus 1 itself, because modulus of m is equal to, you have m itself if m is more than or equal to 0, and minus m if m is less than 0. So if you have the value under the modulus sign is positive, the number will come out as it is, and you'll find that absolute value of x minus 2 will be equal to, if you take a value between 1 and 2, 1.5, become negative. So it becomes equal to negative of x minus 2 is equal to 2 minus x. Therefore, absolute value of x minus 1 plus absolute value of x minus 2 is more than or equal to 4, implies that x minus 1 plus 2 minus x is more than or equal to 4. X and x cancels, giving you 1 is more than or equal to 4, which is absurd, or not possible. Therefore, we don't find any solutions for x between 1 and 2. So no solutions for x belonging to closed 1 to open 2 here. Then going in for case 3, when you have x is more than or equal to 2, you'll find that absolute value of x minus 1 is equal to x minus 1 itself, because if you take a value, let's say more than 200, it's positive. So you have x minus 2 is equal to x minus 2 itself. Therefore, you find that modulus of x minus 1 plus absolute value of x minus 2 is more than or equal to 4, implies that x minus 1 plus x minus 2 is more than or equal to 4. Therefore, 2x minus 3 is more than or equal to 4. Therefore, we find that 2x is more than or equal to 7. Therefore, x is more than or equal to 7 by 2. Therefore, x belongs to 7/2, comma infinity. So if yeah, if you chose your x in the real numbers to be a value less than 1, you will find the solutions for the problem from minus infinity to half. That is, looks like this is negative half here. So you will find solutions less than, if you chose the value until 1 here, you will find solutions only here in this zone. If you choose your value between 1 and 2, you find no solutions here. This is no solutions. If you choose the values which are more than 2, you will find that the solutions are beyond 3.5. 7/2 is 3.5. So beyond 3.5, you'll find your solutions. So all in all, the system has solutions. The system makes sense and has solutions. Therefore, solution set is you have negative infinity right up till negative half, closed, of course, closed negative half, or you have 3.5, that's 7/2, right up till infinity. This is where you'll find that the solutions of the system exist. So this is a very complex system, actually. So if you plug any value which is given by that thing, there you plug a value, let's say less than minus half. Let's say you take minus 10 here. If I minus 10 minus 1 minus 11, the absolute value is 11 here. And then I said minus 10 plus 12 minus 12, so 12 here. You'll find that it becomes more than 4, which is true. But if you take a value between minus half and looks like this is the bad zone, so the solutions are only found here. Solutions are only found, this is 0, this is minus half here, this is 3.5 here. So only if you go to zone which is less than this, or the zone which is more than this here, you will find the inequality mod of x minus 1 plus mod of x minus 4 more than or equal to mod x minus 2 more than or equal to 4 is satisfied. So in this zone, no. In this zone, no, you don't have any solutions. If you plug any value into the inequality here, no value will satisfy that on those conditions. They're more than or equal to 4. So the solution set is only the values from here, either here or here. I think that would be enough for the modulus inequalities, I guess. Yeah. So